In a stunning revelation, NASA has raised concerns about the increasing chances of a giant asteroid potentially colliding with Earth in 2032. Massive celestial objects, including towering asteroids, rogue planets, and even the terrifying threat of black holes, continue to travel perilously close to our planet. These cosmic threats have thrust NASA and other space agencies onto high alert, as experts scramble to decode the likelihood of a disaster. The question on everyone's mind, is Earth truly safe from the wonders and dangers lurking beyond our atmosphere? As scientists and researchers work around the clock to monitor these celestial hazards, one thing is clear: the universe is far more unpredictable and dynamic than we ever imagined. With every passing day, the odds of an impact seem to grow, pushing us to ask the hard questions about our survival in the cosmic neighborhood. Let's take a deeper look into some of the most prominent cosmic threats that could potentially alter life as we know it. Among the most famous near-Earth objects, NEOs, is Bennu, a small but mighty asteroid that has captured the attention of scientists worldwide. Discovered on September 11, 1999, as part of NASA's ongoing search for large space objects that might be a threat to our planet, Bennu was initially known by a different name, 1999 RQ-36. However, as researchers began to study its orbit and trajectory, it became clear that Bennu, a skyscraper-sized rock floating through space, might pass close enough to Earth to warrant serious investigation. Bennu is no ordinary asteroid. With a height comparable to that of a 500-meter-tall skyscraper, its size alone makes it an object of serious interest. Over the years, NASA scientists have used advanced radar and observation techniques to track Bennu's movements, gathering valuable data about its shape, size, and the forces that influence its orbit. One of the most fascinating factors at play is the Yarkovsky effect, a tiny force caused by the way sunlight warms an asteroid, which can subtly nudge its orbit over time. Though Bennu is small, these minute shifts can accumulate over centuries, making its future path harder to predict. In 2016, NASA launched the OSIRIS-REx mission to study Bennu up close. The spacecraft arrived at the asteroid in 2018, mapping its surface and even collecting a sample in October 2020. This sample, sealed in a specially designed capsule, made its way back to Earth in September 2023, providing scientists with ancient rocks and dust that hold crucial information about the early solar system. These pieces could even offer clues about the origins of life itself. While the odds of Bennu striking Earth in the next century are currently less than 1%, ongoing research continues to refine our understanding of this ancient space rock. Though the risk of Bennu colliding with Earth remains low, its story serves as a reminder that the universe is full of surprises. The more we study asteroids like Bennu, the better we will be prepared for any unforeseen dangers that may arise. Another asteroid making waves in the cosmic community is Apus, discovered on June 19, 2004, by a team of astronomers at the Kitt Peak National Observatory. Apus first caught the public's attention when it passed within approximately 9 million miles of Earth later that same year. While this may sound like a significant distance, it's considered relatively close by space standards, leading scientists to closely monitor the asteroid for potential future threats. Initially, some early predictions raised alarm bells, suggesting that Apus could pose a risk to Earth in 2036. However, thanks to improved observations and the advent of more advanced radar technologies, by 2013, scientists confirmed that the likelihood of Apus colliding with Earth in 2036 was almost non-existent, less than 1 in a million. By 2021, detailed data from NASA's Jet Propulsion Laboratory further solidified this conclusion, ensuring that Apus will not pose a significant threat for at least the next century. Despite these encouraging findings, Apus is still monitored closely by NASA and other space agencies. It serves as a reminder that even the most seemingly harmless asteroids can have a far-reaching impact on our understanding of the solar system and the unpredictable nature of space. While asteroids may be the most tangible threats we face from space, we should not overlook the dangers posed by our very own star, the Sun. Solar flares, sudden and intense bursts of energy from the Sun, can have profound and far-reaching effects on Earth. These explosions release massive amounts of radiation and charged particles that hurtle through space, sometimes directly toward Earth. When this happens, the consequences can range from disrupting communications to sparking widespread power outages. The most famous example of a solar flare's disruptive power is the Carrington event of 1859, a geomagnetic storm so powerful that it caused telegraph systems to spark and even set fires. Fast forward to today, and a similar solar storm could lead to massive blackouts, satellite failures, and major communication breakdowns around the world. Solar flares can even disrupt GPS systems, creating chaos for everything from airline schedules to navigation. On the brighter side, solar flares also enhance the beauty of Earth's sky by intensifying the appearance of auroras, the northern and southern lights. These dazzling displays are a stunning reminder of the Sun's power, but they also serve as a visual symbol of just how intimately tied Earth is to its closest star. Thanks to advanced forecasting tools and solar observatories, scientists are now better prepared to predict solar flares, giving companies and governments a chance to safeguard crucial infrastructure. However, the unpredictable nature of the Sun means we will always need to stay vigilant. One of the most mysterious and intriguing phenomena in the universe are rogue planets, planets that do not orbit a star and instead drift freely through space. Unlike typical planets that remain bound to the gravitational pull of their suns, rogue planets are often born when a gas cloud collapses or are ejected from their original star systems after violent gravitational interactions. These rogue planets are difficult to detect because, without the warmth of a nearby star, they emit little light. Recent studies suggest that there could be billions, perhaps even trillions of rogue planets in the Milky Way alone, but the chances of one ever colliding with Earth are incredibly low. Space is vast, and rogue planets are, by nature, wanderers, often far from the path of our solar system. However, their very existence highlights the unpredictable nature of the cosmos. What if one of these cold, dark wanderers crossed paths with Earth? The result would be catastrophic. A collision could potentially trigger mass extinction, creating massive earthquakes, tsunamis, and even a global cooling event similar to a nuclear winter. Fortunately, the chances of such a collision are nearly impossible, but the idea of these mysterious planets drifting through space underscores just how little we truly understand about the universe. These rogue wanderers raise fascinating questions about the nature of life beyond our solar system, and the kinds of cosmic events that could occur in the far, distant future. Adding to the cosmic drama are rogue stars, or stars that have been ejected from their home galaxies and set loose to drift through intergalactic space. The first rogue star was discovered in 1997, and since then, astronomers have realized that these wandering stars are more common than we initially thought. They are usually the result of galaxy collisions or gravitational interactions with supermassive black holes at the center of galaxies. These rogue stars can travel at high speeds, and if one were to pass near our solar system, it could cause significant disruptions. The gravitational pull of a rogue star could alter the orbits of planets, potentially throwing Earth off its course, causing catastrophic collisions or environmental changes. While the likelihood of such an event is exceedingly rare, it still underscores the